Hello, welcome back to Cinderella Math. Today will be a video on finding the domain and range. This can be done with both a relation and a function. If you're wanting to know what the difference is, I have a video on how to determine something if something is a function. That'll be on the pre-algebra and the Algebra 1 playlist if you need to know about that. All right, so yeah, domain and range, super important topic, really all through high school. It does get, more complicated once you get up into those really upper levels. This is going to be geared for folks in pre-algebra or Algebra 1. If you're in a level higher than that, you can certainly watch this. It might be a good refresher for you, but if you're in Algebra 2, pre-calc, all that stuff, your domain and range questions will probably be more complicated than this. Alrighty, so what is domain and range? I'm just going to go ahead and give you a couple definitions right here on this paper. And again, these will come up all through high school math, so good definitions to kind of commit to memory. Domain is the set of x values that makes up a relation or makes up a function. Again, if you're in upper math, your definition of domain might be a little fancier than that. You could also call it the set of inputs. But I just, for the level of this video, I'm going to go with the set of x values, input values. So if domain is the set of x values, range, you could probably take a pretty good guess, is the set of y values of a relation or of a function. And again, could be a fancier definition out there if you're a little bit older or in a higher level math. It could also be the set of output values. But again, for simplicity on today's video, I'm going to be referring to the domain as the set of x values and the range as the set of y values. Okay. Alrighty. Let's get started. All right, so there's a couple different ways this question can present itself. I'm going to white some stuff out here, and let's look at example 1 on your top left. I have given a set of ordered pairs, and remember ordered pairs, this is example 1, ordered pairs come as x comma y, so always that first value is your x, and after the comma, the second value is always your y. Alrighty, so just looking at example 1, if I ask what is the domain of this, it is the set of x values. So I'm going to go ahead and circle the x values in red, so all the beginning numbers before the comma. Alright, remember in math to do a set, you do squiggle bracket or curly bracket. Some teachers call it a brace, you do whatever you want. And then it is preferred that you write these least to greatest. It's not wrong if you don't. It's just kind of, preferred. And it's just what most teachers will do themselves, so they would like their students to do that. So looking at the numbers I have in the red box, the smallest is -8. The next smallest is -6, then 0, then 6. So yes, I was nice and already had them least to greatest, but that will not always be the case. And that's it. Put commas in between because it's a list, and put your curly brackets because it's a set. It's a set of x values. And now let's do the range. So remember the definition of range is the set of y values. So I'm going to circle the y values here in blue. And then again, you're going to make your curly bracket because it's a set. And it's preferred that we go least to greatest. So looking at the blue, the smallest one is -6. Next smallest is -4. Then -2. Then 10. Close your bracket. Commas in between because it's a list. And that's all there is to it for a set of pairs. Let's look at example 2. Domain, I'm going to circle the x values in orange. So we have 5, 6, 5. And yep, 5 does occur twice. So that would not be a function. Again, watch that other video that I referred to a second ago if you want more info on that. But that's still domain, is still the x's. We still do our set. Least to greatest, we have 5, 6, 5. So what's the smallest? 5. And there's 2 of them. You do not need to repeat yourself. So even though yes, indeed, there are 2 5s there as x values, you don't usually go like that. There's no need to repeat yourself. So let's just write 5 once, and then 6 is also part of the domain. Close your bracket. If you repeated yourself, most teachers probably won't count that wrong. They would probably just make like a note on your paper, but you might as well just save yourself time. If you don't need to write it, don't write it. So no need to repeat yourself if you want to make that note. Don't repeat values. So even if they repeat, you do not need to. And the range on this one, I'll be going with green. Range, of course, is y values. Putting those in a green box. Least to greatest would be 9, 10, 11. So a lot of people think this is wrong because they're like, hey, wait, the domain only has 2 values and this has 3 values. It's because the 5 repeated and we don't repeat ourselves. So people are like, oh no, that must be wrong. It's not, it just means something repeated. That's all. All right, pause me there if you're still copying anything, because I'm about to white that out. And we're going to look at some charts. Some teachers call them charts. Some teachers call them tables. It doesn't matter. Whatever you call them is fine. I'm going to white that out. All right, so let's look here at example 3. So our domain for example 3, just look down the X column. So squiggle, least to greatest, 1, 3, 6. So yes, they were already in least to greatest. That's nice. Range, just put your eyeballs down the Y column. 2, 2, 9. Oop, repeat. That's okay. Just write it once. So 2, 9. Done. That's it. Love a chart. It usually is very fast. Let's come to example 4. One more chart here. Domain. Again, run your eyeballs down the X's. Oop, 1 repeat. So that would not be a function. Again, refer to that other video. But we can still give the domain. 1, 3, 1. So the lowest would be 1 and then 3. We don't need to repeat ourselves. Even though 1 did repeat, we don't need to. And finally for this one, range. Example 4. Range. Look down the Y's. Least to greatest, 2, 5, 9. And again, if you don't do least to greatest, most teachers aren't going to count it wrong. Really uptight ones could, but they probably will make a note. It's just kind of standard process to go least to greatest. Let me do one more chart table. It is possible that your tables go horizontal. I should have set one up like this. I just didn't think about it until right now. It is possible that your X's are like along the top row and your Y's are on the bottom. So let's call this one example 5 that I just wrote up there in the black. For domain, you would just look across your X row. So across the top row, 1, 3, 7. So those are already least to greatest. Don't forget your squiggle. Don't forget commas. And close the squiggle. Range, you look across the bottom row there. Okay, so in pink, range, don't forget your squiggle. Smallest is -8. Next smallest is -1. Biggest is 0. Okay, so it is possible to have horizontal charts. Just wanted to show one of those. All right. So those, we now know how to find domain and range if they give us a chart or table, and if they just give us a list of ordered pairs. I need to switch my slide here and go to some graph paper, because what if they give us a graph? These are probably the hardest, and they probably also take the longest. So first of all, I'm going to start off with a discrete graph. You don't really need to know what that word means. It just means if the points are not connected. So let me just kind of put some random points on here. This may be a function. It may just be a relation. Again, check that other video if you want to know what I mean by that. But we can still give the domain and range whether it's a relation or a function. Okay, What you want to do is you want to write down these points. So it is a little bit annoying. I like to go left to right like you're reading a book. So start on your left, go to your right, you know, the dog barked. So go this way. Start left, go right like you're reading a sentence. Okay? So go to your very far left point. So I'm going to put a red check and then let's write down that point. So that looks to be -7, 5. Keep going, making your way to your right side. This one, and -4, 7. Here, -2, 2. And here, 4, 4. And final point all the way to the right hand side, looks like it's over 8, up 10. And again, I just put those on randomly. Commas in between because it's a list of points, and squiggles because it's the set of points represented by that graph. And now we can give domain range. And here's the pro to going left to right. Your domain should already be least to greatest. So remember, domain is x's. This is already least to greatest because you went left to right. Nothing repeats, so that's nice. If it did, again, we just wouldn't write it twice. We would write it once and then be good. So domain is x values, range is y values. Now these may not be in order. So I'm putting green boxes on my y values, and then I need to go least to greatest. So from those green boxes, it looks like 2 is the smallest, 4, 5, 7, 10. Again, we didn't have any repeats on that, but if we did, we would have just written it once. So that is a little bit annoying. You got to take the time, grab some scratch paper, write down your points, be done. Okay? Here's the hardest thing. And if you're in pre-algebra, you may not even do this next part in pre-algebra, but if you're any level higher, you probably will. This will be called a continuous graph. If you're in like Algebra 2 and beyond, you'll work with non-continuous graphs as well. But that will not be in this video. Actually, let me do one thing first here before I put arrows. There we go. So you cannot write down all the points that are on that line segment. You can't. There's actually an infinite number of points on there. I know that sounds silly, but there are. So what do? For your domain, which again is x values, you're going to look with your eyeballs from left to right. Okay. So how far left does this go? Kind of build a little wall. This is the farthest left. And what's that number? -6. Write that down. Comma. How far right does it go? So look with your eyeballs all the way to the right. How far right? Build a wall. There we go. There. And now, since we have solid dots, we're going to put brackets on these. Square brackets. Okay? That is one way we can write it. Or we're still going to write down that left number, which was -6, skip a little space, and write down your right number, which was 8, x in between, and make kind of a little x sandwich. And we will need the equals. And again, why the equals? Because we had solid dots. I'll show you an open dot in a second. Okay, if you're older, you're probably going to be doing the bracket one. So if you're like Algebra 2 and above, probably the bracket one. Okay, how about range? So again, there's no way we can write down all those points. Range, you're going to look down to up. And my joke is you play limbo. How low can you go is what you ask yourself. Okay, so I'm going to take off these walls. Play limbo. How low did this graph get? And you're looking at your y value. So how low? -3, write that down, comma, how high? 8. And again, because of those solid dots, we will do hard brackets, square brackets, or still write down your low number, still write down your high number, and put a Y in between, because Y is, range values are Ys. Make a sandwich, and we will need the equal because of open dots. This is tricky, okay? Give yourself a little bit of grace here. Give yourself a couple examples to catch it. This takes a little bit. Okay, let me do one with open dots real fast here. So domain, you look left to right. Build a wall on the left. So the farthest left this goes is 3. The farthest right this goes is 8. And you will do soft parentheses because of those open dots. That means it actually didn't touch 3 and it didn't touch 8. It got close, but not quite. Or again, write down your left number 3, your right number 8. Put X in the middle because domain is X values. Make a sandwich with less than signs, but you will not put the equals because open dot means it does not equal it. Okay, that would be domain. And range, you're going to look low to high or bottom to top, whatever you want to say. So how low do you go? Play limbo. Looks like 4. How high do you go? Looks like 10. You would do soft parentheses because it doesn't actually touch 4 and it doesn't actually touch 10 because of those open dots. Or write your low number 4, your high number 10, put a Y in the middle, make your sandwich. We will not need equals because of the open dots. Okay, let me do one that's connected. So like, like a circle. I know that's not a great circle. Bear with. Thank you. Okay. Domain, left to right. So the farthest left this goes is -3. The farthest right it goes is 3. And you would do hard brackets there because it did touch. There's no open dots. Or -3, 3, X sandwich, and you would include equal because again it did touch. There's no open circles. Range, how low? -3. How high? 3. Solid brackets because it did touch, or -3, your low number, 3, your high number, Y in between, make a sandwich. You will need the equals because it touched with no open circle. So that is a coincidence that the domain and range is the same. That certainly does not always happen, but it's kind of cool when it does. All right, now we'll go on to the truly tricky part here, is where the function goes on forever, or the relation, whatever. So let's talk about just a line, any old line, arrows on both sides. This is where people get stuck, and it's understandable, it's hard. Domain, you're still going to put your eyeballs on there and look left to right. And here's where a lot of people go, okay, left, -8. No. See this arrow? That will keep going forever. It will keep going to like -11, -12. negative 100, negative 1,000. It will keep going left forever. It will go left and left and left to negative infinity. And you're always going to do a parenthesis on that, never a hard bracket, because we don't ever actually hit infinity. Like it's not a number that we can touch, right? Now look to your right. So again, a lot of people would be like, oh, 8 or 7. No. Look at that arrow. That will keep going to your right forever. So again, this will go 11, 12, 100, 1,000,000. Forever. Infinity. So your left is negative infinity, your right is positive infinity. If you're kind of on the younger side, infinity is new to you. It does take a little practice to write it. It's basically just an 8 sideways. Another way to say negative infinity, comma, infinity is that it could be anything, right? Anything in the whole world. So another way to say this is to spell out all real numbers. And that actually happens so much, there's a mathematical symbol for that. It's a capital R with an extra bar on that left side. So all of these are actually correct. Here, here, and here. All right? It will depend on your teacher which one they want. Certainly if you're older, like Algebra 2 and above, you're probably going to do the infinities. If you're a little younger, ask your teacher. Okay? They're all right, though. Okay, so that was left to right, so that was our domain. Now let's talk range. We are still going to put our eyeballs on there and run it low to high. So range, low to high, or bottom to top, whatever you want to say. So people will be like, oh, here's the bottom, negative 10. Boom. No. Again, look at that arrow. It is going to go down forever. So negative 13, negative 14, negative 100, negative whatever, forever. So down forever is going to be negative infinity. Okay, now let's go high. How high does it go? Oh, 9. No. Look at that arrow. Up forever. Infinity. Or you can spell out all real numbers. And again, that happens so much that it got its own symbol, R with an extra bar. They're all right. Ask your teacher which one they want. You don't need to do all 3. Do whatever your teacher wants. Okay. Alrighty. I think, well, I'll do one more of those. And then this will be it. Okay. If you're in Algebra 1 or higher, you probably know that this shape is called a parabola. But even if you're not in that level, it's fine. You don't really need to know that that's what this is called for this problem. Domain, left to right. This one, left forever. So people think because it's going up, it'll be positive infinity. No, this will keep going left, right? So negative 11, negative 12, negative 100. Left forever, so negative infinity on your left-hand side. If it helps you, just go ahead and put negative infinity up here on your left. And then this one, again, right forever. So right forever is positive infinity. Or all real numbers, which is the R with the extra bar. Again, you do not need all 3 of those. Do whatever your teacher wants. Left forever, right forever. How about range, though? It is not forever. So range, how low can we go? Right here. That does not go down forever. That stops. It goes down to negative 8 solid because we do touch. How high does it go? Both of these arrows will go up forever to infinity. Or You can say y is bigger or equal to -8. It's kind of has a floor at -8 and then it goes up from there. Again, if you're older, you're going to want to do this first one. If you're a little on the younger side, you might do the second one. Again, it doesn't matter. Potato, potato. Do what your teacher wants. Okay. Now have I hit it all? I hope so. I'm just looking through my notes here. I think I have. Oh, hold on. I see one thing. What if it's just like a flat line? Still has arrows on both sides. You still just run your eyeballs. Okay, so domain, left to right, this arrow left forever. So -infinity on your left, this arrow right forever, infinity. Range, how low to how high? Well, it just stays flat. So what is that y value? Right there, it is on 6 the entire time. So you can just put 6 in his own little squiggly. Or you could just say y equals 6. It never goes higher than that. It never goes lower. Flat. Okay? If it was a straight up and down line, so a straight vertical line, like this. Oh my gosh, I'm horrible at drawing a line. Pretend that's actually straight. You would say domain, well, left to right. Well, it doesn't go left. It doesn't go right. It is stuck on -3. So you would just say -3 in his own squiggle, or x, because domain is x, equals -3. But the range on this one, this arrow goes down forever to -infinity, and this one goes up forever to infinity, or all real numbers. Okay. There are certainly more examples of these, especially if you're in those upper levels, Algebra 2, Pre-Calc, and beyond. But this aim of this video was more pre-algebra, Algebra 1, and I think if you're in those levels, that should have covered everything you need on this topic. I hope you're having a great day, and just leave me any questions or comments in the comments below. Hope to see you again soon. Bye-bye.